Hi, Logic students. This is a video on section 1.5 in our textbook, A Concise Introduction to Logic by Hurley. This section is devoted to counterexamples. So the first thing we have to explain is what a counterexample is. And basically, a counterexample is an example that you give to prove that a person is wrong, is doing something incorrect or believing something incorrect. Here's like a simple example. Imagine there's a person who doesn't really know much about contemporary literature, and this person says, well, there aren't really any important contemporary female writers who are African American. So how do you respond to a person who is making this kind of comment? Well, you can give a counterexample. You can give examples of contemporary female African American writers who are very important and well known all over the world. So there's Alice Walker, who wrote The Color Purple. There's Toni Morrison, who is a Nobel laureate, and there's Maya Angelou, who's a famous poet as well. So these are all counterexamples to the claim that there aren't any important contemporary female writers who are African American. When it comes to reasoning and logic, a counterexample is not just a statement to the effect that there is something that disproves a statement made by somebody, but a counterexample is more like an argument that shows that another argument is invalid. Not an argument that goes against the original argument, but an argument that has the same structure of the argument that you want to refute, but is clearly invalid. So it's almost like you're saying to a person, if you reason in this way, you're reasoning incorrectly. And I can show you, I can make an argument that has exactly the same structure as yours, but is clearly invalid. Here's an example, a very simple one that serves to illustrate the point. Suppose that a person makes this argument. All communists are progressive, therefore all progressive people are communists. And you want to show to this person who's making this argument that the argument is incorrect, that it's an invalid argument. So what you can do is produce a counterexample, meaning you can build an argument that has exactly the same structure as this one, but is obviously invalid. And it's going to be an argument that has a clearly true premise and a clearly false conclusion. And by doing this, you show that the structure of this original argument, or all communists are progressive, therefore all progressive people are communists, is actually a faulty structure. It's an invalid structure because you can build an invalid argument on it. So the steps to creating a counterexample are three. First, you take the original argument and you write it down in a kind of standard form. First, the premise or premises, if there is more than one premise, and in this case, there's only one premise, and then the conclusion. So you place the premise or premises first, and then the conclusion. And then the second step will be to state the form of the argument, to kind of strip out the content and state the basic structure of the argument. And here's how you do it. You rewrite the argument. And then you look at the categories, at the types of things or people that are mentioned in the argument. For example, in this argument, there are two categories or two sets, communists, which are mentioned in the premise and in the conclusion, and progressive people, again, in the premise and in the conclusion. So what you do to state the form is you leave everything as it is, but you replace the categories with letters. And you do this uniformly. So for each category, you use a single letter. So for communists, you might use the letter C. You use capital letters of the English alphabet. So you just scan the whole argument and replace all occurrences of communists with a capital C. And you do the same for the other category. Progressive people, the most natural substitution would be P. You could have used the letter A and the letter B. It doesn't matter, as long as you do this uniformly. So all occurrences of communists will be replaced by the same letter, in this case, C. If you pick another letter, you'll be using that letter throughout, and the same for P. So now you have the form of the argument. Really this is the basic structure of the argument. The structure asserts that there are two sets of things or people, C and P, and that all C's are P. And from this, the argument concludes that all P's are C's. And I think you can see fairly easily that this is not a very good way of reasoning. When you have two sets of things and all members of the first set are members of the second, that doesn't necessarily go both ways. That also all members of the second group are members of the first group. And so you can fairly easily build a counterexample. That is an argument that has this structure, but has an obviously true premise and an obviously false conclusion. So what you do to build the counterexample is you take the form, you write it down by itself, and then you try to find two categories, C and P, that will make the conclusion false and the premise true. And it's fairly easy to find these two categories. For example, you might say all mothers are women. And because mothers was used as a replacement for C, you would put mothers down here, and women is a replacement for P, so you put it down here as well. And you can see that this is clearly an invalid argument. All C are P, therefore all P are C, has a counterexample. All mothers are women, therefore all women are mothers. All mothers are women is true, but all women are mothers is false. So again, the counterexample takes the original form and uses it to build an argument that has a true premise and a false conclusion. So this proves conclusively that this form is invalid, because if it were a valid form, you wouldn't be able to construct an argument that has that form, a true premise, and a false conclusion. Let's see how this works with an example from the textbook. For example, let's take this number 1. Okay, so this is our argument. All galaxies are structures that contain black holes in the center. So all galaxies are quasars, since all quasars are structures that contain black holes in the center. The first thing you want to do here is figure out which statements are the premises and which statement is the conclusion. And here you can see that there's a conclusion indicator. So the statement, all galaxies are quasars, is the conclusion. This is one of those arguments where you get a premise first, and then there's the conclusion that is sandwiched between the first premise and the second premise. This is the second premise, and you can tell because it's introduced by the premise indicator since. So let's rewrite the argument in standard form. First the premises and then the conclusion. We'll put the first premise first. And then the second premise. And finally, the conclusion, we'll just write therefore to remind ourselves that this is the conclusion. Okay, so now the argument is in standard form. And we can proceed to extract the form of this argument. So you may want to copy it down again. So that you can keep the original in view as you strip down the content and exhibit the form. So here there is talk of three categories: galaxies, structures that contain black holes in the center, and quasars. So what you want to do is you're not going to touch anything else, but you're going to replace all the galaxies with G, all the structures that contain black holes in the center with S, let's say, and quasars with Q. Now you have your form. Notice that I didn't touch these little words like all. These are very important words from a logical standpoint, so you don't want to change them in any way, otherwise you would be changing the whole argument. And now we can create a counterexample. That is, we'll take this form and we will rebuild another argument, one where it's clear that the premises are true and the conclusion is false. And our textbook gives two good suggestions for doing this. The textbook says, start with the conclusion and try to make it false, and then work your way back to the premises. And it says, keep it simple. Use simple categories whose relationships are well understood. So here I'm going to try to do something crazy. I'll just play around with animals. What will be a false statement about animals? Something like all lions are hamsters. So G, I'm going to put in lions, and Q, hamsters. So now clearly my conclusion is false, all lions are hamsters. And now I need to find a substitute for S that will make both premises true. It's very easy to do that. I could say all lions are animals, all hamsters are animals. Those are definitely true statements. Or all lions are mammals, and all hamsters are mammals. And now I have my counterexample. The premises are true. All lions are mammals, all hamsters are mammals. But the conclusion is obviously false. And the reason is that this is a bad form. All the exercises in section 1.5 are arguments that are invalid, and the task is to prove through a counterexample that they are invalid.